Good evening. Now remaining two problems we will solve. That is problem 9 and problem 10. Now for this we are going to use Macaulay's method. Because for UVL Macaulay's is preferable. Now we are going to make two parts of this. So I will go for this. So we can have one part, I will say, that is UDL. So we have this will be UDL, and this is 5 kilonewton per meter. So we have this will be 5 kilonewton per meter. So 5 kilonewton per meter. And if we will consider X, so what will be bending moment for this? So we will get M due to this is equal to minus 5x total load into x by 2 will be bending moment. So we have considered this rectangular part. Now we have this triangular part. Now value of this is total 10, 5 that we have used. So remaining is again 5 kilonewton per meter. So we have triangular load. And this is 5 kilonewton per meter. So distance is 5 meters. So we have this will be 5 kilonewton per meter. Then we have this again x. So vertical distance, let us we will say is y. So now relation, similar triangles, we have y by x equal to, we have this value 5, this value 5. So 5 by 5. So we will get therefore y equal to x. Now we have to take bending moment of this. So how we will get this? So we have this will be now x. Then we have vertical also, we will have y equal to x. So total load we have that is 1/2 base into height. And then we have this centroid, this will be from this side. So we have 2/3 of x. Then what will be bending moment? So we have M is equal to 1/2 into x into x. Sorry, we are going to take bending moment at x. We are taking here. So we have this will be x by 3. So we have 1/2 x into x. So bending moment at x. So we have to consider it as x by 3. So we will get M is equal to, again from right anti-clockwise minus. So we have minus x cube by 6. And so when we will consider this total trapezoidal load at a distance x, then we have combination of these two. That is minus 5x square by 2 and minus x cube by 6. So you can see we have this as Macaulay's equation. So we have this first due to UDL minus 5x square by 2 and due to UVL x cube, and that is 6. So we have this is equation of bending moment. Then we will integrate it. So integrating above equation. Integrating. So just remember Macaulay's method. Integrating above equation. So we have EI dy by dx equal to minus 5x cube by 3, and this 2 becomes 6 minus this is x cube by 6. So we have x cube by 6. So it becomes x4 by 24 plus 7. Now we know we have this as fixed end. At fixed end A, we have y, dy by dx is also 0. And we have y is also 0. Both are 0. So we will put at support x equal to 5 meter, dy by dx equal to 0. So we will substitute value in this equation. So this becomes 0 minus 5. X is 5. So 5 cube by 6 minus 5 to the power 4 upon 24 plus 7. And we will get value of C1 as 3125 upon 24. Then we will go with integrating above equation. So we will integrate this equation. What we will get in that case? So EIY. So now just see this equation we have minus 5x cube upon 6. So you can see minus 5x cube upon 6. So it becomes minus 5x 4 upon 24. Second term we have minus x4 upon 24 becomes minus x5 upon 5 into 24. C1 value we have 3125 upon 24. You can see plus C1 into x. Now we have integrated it. So we have 3125 upon 24x plus C2. And now we know at fixed end, support A, we have y0. And then from this, we will put value of x as 5. And if we will substitute all these values, then we will get value of C2 equal to minus 11875 upon 24. And from this, we will get equation of EIY. So we have substituted values. So minus 5x4 upon 24 minus x5 upon 5 in 24 plus 3125 upon 24x minus 1187 upon 24. Now we are interested to find value at x equal to 0, free end, y equal to yb, and then all these term become 0 because this term, and this term, these are included with x, and x we have 0, and therefore EIYB is minus 1187 upon 24. So YB is minus 11875 upon 24 EI and 11875 upon 24 EI. So we have option that is C. So we have C option over here. And then we have last. So we have given this. So always it is preferable to use triangular side to write the equation. So in this case, we have to find reaction and we have to find moment. Now reaction, if I will say VA, so we know total load will be carried by VA. So if I will write equation summation Fy equal to 0, so we have VA minus 1/2 into base into height, and that is equal to 0. And from this we will get VA as 72 kilonewtons. So VA value we have 72 kilonewtons. Now bending moment. So where it will act, so this will be total 72 kilonewton. And it will act at 2/3 from this side. So 2/3 of 4. And then bending moment from this we will get 72 into 8 by 3. So 3 we have 24 and then 2, 3. So 192 kilonewton meter. So now we have these values 72, 192. This is 36 kilonewton per meter. And now we will consider x and y. So now how we will get this relation again? So we have y by x equal to 36 upon 4. And from this we will get y is equal to 9x. So we have this y that is equal to 9x. And then how we will write this equation if I will take this separate? So we have this will be 9x. So 9x, this will be x. We have this at 72 kilonewton. And bending moment we have 192 kilonewton meter. And then this will be act at centroid. And we have this distance. Now we have to take moment at this point. And so we have this will be x by 3. So we have x by 3. Then what will be total load? So we will calculate this total load. So we have 1/2 into x into 9x. This will be total load. And then what will be bending moment? So I will write P. And then what will be M due to triangular load? So P we have 1/2 into x into 9x into x by 3. and then we will get it as 3x cube by 3x cube by 2, or we can write 1.5x cube. And now we will write equation. So we have this equation. Now you can see. So this, we have already seen. So I will just rub this part. And then you can see we have this equation 72x. So we have actually this reaction. We have 72. So we have this will be 72x minus bending moment need not require to multiply by distance. So we have 192, and then we have this 1/2 x into 9x into x by 3. So this value we have same where we have this value. So this is equation of moment. Then we will integrate it. So by integrating, we have integrating. So we have this value, that is EI dy by dx is 72x square by 2 minus 192x minus, so I already mentioned 1.5x cube. So it becomes 1.5x 4 by 4 plus 7. Now we have initial, that is at x equal to 0. Now we have a as fixed. So at a, we have x 0 because x is measured from here. And then x equal to 0, we have dy by dx 0, and we have y equal to 0. So if we will put a value at x equal to 0, dy by dx 0. So this value 0, this becomes 0, 0, 0. And therefore, C1 becomes 0. Now again we will integrate it. So integrating. Then what we will get in this case? So we have 72x cube by 6. So this integration of this part, minus integration of this part, 192x square by 2, and minus 1.5x 5 upon 20 plus C2. Again we know at support A, we have y0. So again, therefore we will get value of C2 equal to 0. So now we will get equation of EIY in this fashion. We are interested at B, free end. At free end, we have x equal to 4 meters. So put value of x equal to 4 meters. We have y equal to yb. And if we will solve this, we will get EIYB as approximately 845, or I can write yb equal to minus, we will get it as minus 845 upon EI. So now you can see this 845 upon EI means which option? So we have option A. So we have for this option A. Now we have question 1 also. I have given option D, but change it. Our option, that is A, only beams. So if you will go to this question number 1, so just I will go there. So we have question 1, which I marked it as D. So instead of this, you take this as A. I have made it correct. So you also make it correct A, because theory there is a problem what they are interested with this. So now with this, we will stop here only. Remaining part we will see in the next video. So thank you.